Okay, I'm working on my rotating disc inverters, something to run the rotoverter with. It's very simple. You have two magnets facing same pole outward, and it'll come by and turn this MOSFET on here. Then it'll come by, turn this MOSFET on, come by and turn this MOSFET on, then turn this MOSFET on. So you can make AC from DC. And then I have a pulse width modulator that controls the speed of this. And you get it going like 1800 RPM. And that'll be 60 hertz signal it'll put out. For example, here's one I just made, a little bit better looking. This computer fan motor, you run it on 9 volts, and it'll require 30 milliamps to spin this. And so the idea is I'll have a stack of caps filled up by a DC to DC boost converter to about 85 volts. And I'll have another one. And they'll alternate via this rotating disc triggering MOSFETs, which one will fire. And so you make AC through DC to DC boost converters. Here's an old one that I tested. These solid state relays are pretty slow, but you can do 60 hertz, but not much more. And so I have 2 here and 2 here. It makes it real simple hooking up relays. Doesn't matter which is high side or low side. And this is the same thing. So what you do is you get it going, and then you can move this slightly back and forth and make sure the AC sine wave is like real even, like you know, this one's right in between this one, you know, it's all, and so you can get that just by moving this slightly, and then when you get it, then glue it or lock it in place. So I want to run this by all you brains out there. So instead of these relays, I'd rather have my little MOSFET circuits I use all the time with a 4421 chip. There's an N-channel MOSFET and then a Hall effect. And you can also take the flyback collapsing field stuff, or whatever you call it, out of these with a single diode going into a cap, and it works really well. It's on the low side of the inductor. So anyways, what I'd like to do is send in power, one of these this way and then one of these the other opposite direction. And I could also be taking the back EMF, even though that's not the right term for it. The flyback I can also be filling caps with in each. And these operate really fast, so I should be able to do some good speed using these instead of the solid state relays. So let me show you this circuit. Now, they're both N-channel MOSFETs. Let me get something to... These represent a battery powering one of these boost converters and a capacitor. So let's just say that's a capacitor filled by a boost converter. Now, it seems to me the simplest way is just to put a diode here and a diode here. And these are both N channels. I'm not doing a P channel, but just an N channel. And it seems like it'll work. Trace it. Power comes in right to the inductor first. Goes through the coil, the inductor, which would be the rotverter phases. And then it comes into the source of the MOSFET, switches on, and goes back. And this one does the same thing. Comes through the inductor first, comes back to the source, and then the drain switches back to the power supply of the capacitors, filled by the DC to DC boost converters. I'll be having 85 volts in each of these because that's what I set my boost converters to. Now, the diode, this diode will block, when this is on, it'll block it from going back and messing everything up, going back over here, this diode, but this diode will let it through. Well, when this one switches on, this diode will block everything, stuff going back, messing everything up, but this diode will let it through. So seems like this will work pretty good. And now I'll have AC from DC. So I guess that's about it. I'll link my tests I did a while back down in comment section of this thing. And that's about it for exciting news. Okay, thanks for watching.